before we discuss the next subtopic or the last subtopic for today, and I will discuss this first. I just go through the answer quickly so that you can check yours. Okay. So we start with question 2. Alright, this question asking about find the probability of compound event. So we have intersection, union, and also conditional question here. So the information that given here is suppose A and B are independent events. So this is very important statement. A, B are independent event, and given probability of A is 0.25 and probability of B is 0.48. So next is we need to find all this. Probability of intersection AB, union AB, conditional A given B, A given the complement of B. Okay, so I will go one by one and show you the answer. Okay, like I said just now, the statement A and B independent is very important. Okay, so make sure that when it says independent, okay, you must refer to a suitable formula to answer probability of compound event. Okay, so for part A, find the intersection of A intersect B. So because of A and B are independent, you can straight away apply a special multiplication rule. So here I apply special multiplication rule. Okay, that is for A, and for B. Usually when we want to find the probability of union A, B, kalau you nak guna special addition rule, the condition of events must be a mutually exclusive event. So in this case, we cannot say anything about mutually exclusive because if you remember last class, at the end of the subtopic, I show you the summary for independent and mutually exclusive. It says that independent and mutually exclusive cannot occur together. So since now A and B are already independent, so we cannot say that A, B are mutually exclusive. So that's why I didn't use special addition rule here. Okay, I'm just using a general addition rule for finding probability of A union B. Okay, that is AB. If you think that something wrong with my calculation or you need me to explain more, just let me know. Okay, that is AB. And for the rest, C, D, E, F, all the question asking about conditional probability. Okay, and if you notice, what I do is, I'm not using a formula conditional. Okay, I'm not using formula conditional. Okay, for example, C, finding probability of A given B is equals to probability of A. Why I do this? Because of the statement A, B are independent. Okay, this is true when A, B are independent. You boleh cari dalam notes. Kita ada discuss last week. If A, B are independent, then can conditional jadi macam ni. Okay, so you boleh check balik lah. Okay, sama juga. Yang bawah-bawah ni pun, kalau you notice, I don't do any calculation here. Okay, just ambil je. Okay, kalau macam ni, dia akan sama dengan probability yang dekat depan. Ni probability of A equals probability of A equals to probability of B equals to probability of B. But be careful, this is a B complement and A complement. So kalau kita kata kita nak buat macam ni, meaning that A and B complement are independent. And it is true actually. Kan kita kata, kita ada bincang hari tu kan, if A, B independent, automatically they are complementary also independent. So that's why on part D and F, okay, I also assume that A and B complement are independent. So I can use this formula. Okay, if let's say you didn't use this one and you use the complete formula of conditional, you actually will get the same answer. Okay, macam C kan, you guna formula probability of A intersect B divide by probability of B. Okay, you akan dapat 0.25 juga. Cuma banyak kerja sikit kat situ. You kena cari intersection AB and then divide by probability of B. Okay. Tapi you akan dapat jawapan. Sama juga jawapan ni. Okay. So basically ni cara saya buat lah. Kalau awak buat guna formula pun tak ada masalah. Tapi make sure jawapan dia sama. Kalau jawapan lain, meaning something wrong with your calculation. Mesti sama macam ni. Okay, that one is question number 2. So ni apa yang I buat. Okay, and then I also ask you to try question 7. Okay, question 7. This is about a shipment of grapefruit containing the following proportion types. So kalau you tengok kat sini, they give percentage. So what is percentage actually? This percentage actually refer to the idea of probability. So ni tapi dalam bentuk peratus. So how do we change percentage into probability? Okay, let's say 10%. So how do we change it into probability? So dia akan jadi, kalau kita nak tahu probability of pink seedless. Okay, ni grapefruit. Ni dia punya karakteristik dia, event dia. Untuk grapefruit tu event dia pink seedless. Warna pink dan dia tidak berbiji. Okay. So the probability of the grapefruit for being pink seedless is 10%, meaning 0.1 or 10 divided by 100. 10% meaning 10 divided by 100 or 0.1. Okay, for 20%, okay, the probability of the grapefruit being a white seedless is 20% or 0.1. Okay, sorry, 0.2 or 20 over 100. So 20 over 100 is 0.2. So same with 30% and 40%. Okay, so for this one, ni tak ada benda lain pun, dia probability juga, cuma cara penulisan dia letak dalam bentuk peratus. So you just change it into probability form. Okay, dalam bentuk decimal, 0 point something. Okay, a grapefruit is selected random from the shipment. Find the probability that. So we need to find all this probability. Okay, for A, B is just a single probability. Find the probability of grapefruit being seedless, grapefruit is pink, and then now C, D, E, F, this is compound. C is intersection, D is union, okay, E and F is conditional. How I know conditional? Because of the term given. Okay, sebab ada perkataan given kan. So bila ada perkataan given tu, that means it is a conditional event. Okay. Okay, now I show you one by one the solutions. Okay, before I do the solutions, yang warna merah ni solution saya. Okay, yang atas ni I transfer yang tulisan percentage tadi dalam bentuk probability. So tadi ada 10%, 20%, 30%, 40%. So I change it into probability. So it becomes 0.1, 0.2, 0.3, 0.4. Okay. So A, tadi dikatakan find the probability that it is seedless. Okay, grapefruit is seedless. So meaning that we want to find the probability of grapefruit seedless. So meaning we need to consider only grapefruit seedless. Doesn't matter it is pink or white. So maksudnya kita ignore colour dia. So kat sini mana yang seedless? So you akan consider, you only consider yang ni lah seedless dengan yang ni. So yang bawah tu you tak ambil. So tak kisah pink atau white, so you consider both. So what you do is just add them. Tambah saja 0.1 plus 0.2. Okay. And how about pink? Okay, kalau pink, doesn't matter it is seedless or with seed, ada biji ke tak ada biji ke. Ni, as long as the colour is pink. So you need consider 0.1 and 0.3. Okay. So untuk A, B ni you just tambah saja. Okay, add up all this seedless and pink. Okay, kalau yang ni ignore colour dia, yang A ignore colour, yang B ni you ignore dia punya seed. So you ignore the seed. Okay, this is single event. Okay, for C and D, it is a compound. Okay, number one tadi dia kata pink and seedless. So pink and seedless meaning the colour of grapefruit is pink, seedless. Sebenarnya jawapan dah diberi dah ni. Jawapan dah diberi dalam statement, which is this one. Ni intersection lah ni. This is the intersection. Pink, seedless. So kalau you tengok yang lain ni, tak ada karakteristik yang ada dua-dua. Dia tak ada pink, seedless. Yang ni, this is, okay ni bukan. Yang bawah ni bukan. Yang ni pun bukan. Yang ni lagilah bukan. Okay, white kan. So yang ni je. So the answer is 0.1. There's no calculation needed here. There's no calculation. Tak ada calculation pun. Okay. But for D, this is also compound but union. Okay, kalau union, you kena faham union tu apa. Union maksudnya we need to consider all pink and all seedless. Okay, all pink and all seedless. Sebab tu tadi you tambah ni. You tambah pink, you tambah seedless. Nah, you tambah pink. Mana dapat pink and seedless? Yang ni awal-awal. That's why they ask pink and seedless on AB. So you have pink, you tambah dengan seedless. So kalau you masih ingat, if you still remember, special addition rule, dia ada tolak dekat belakang sebab bila you tambah pink dengan seedless, you ada buat benda dua kali, double. Kan? Dia ada redundant dekat tengah-tengah tu. So that's why we need to minus the intersection. So tolak 0.1 ni is actually minus the intersection of pink seedless. Sebab dia jadi double. You tambah pink dengan seedless ni 2 kali. Okay, you add twice at the intersection part. So that's why you need to remove it. You need to remove one part of the intersections. Okay, so this is how we do D, probability of pink union seedless. Okay, and lastly is the conditional part, question E and F. So if you refer to question E and F, dia guna dua-dua. Dia guna benda yang sama sebenarnya, pink seedless. Yang ni tadi dia kata find the probability of pink given seedless. Yang ni pula dia kata find probability of seedless given pink. So nampak macam sama tapi kalau you tengok jawapan dia berbeza. Okay, first find the probability of grapefruit being pink given it's seedless. Okay, of course you will apply the formula. You tak boleh guna yang independent punya idea sebab dia tak ada sebut apa pasal independent pun dalam ni. So you cannot simply kata okay this is equals to probability of pink, which is wrong. So you kena guna formula yang lengkap. Okay. Okay, applying the formula untuk T, jawapan dia 0.3333 or 1 over 3 1 over 3. This is 1 over 3. Kan? Betul kan? Ini ke 1 over 3? Ke 3 over 10? Betul lah. Okay, 1 over 3. Okay. And for part F, it's seedless given pink. Sama juga, you akan guna formula and the answer is different. Tadi you dapat 0.3 but now for F you get 0.25. 0.25. So nampak beza kat situ. So be careful when you want to do a conditional probability. Make sure you confirmkan dulu mana satu yang kat depan. What is the question one? Probability of seedless or probability of pink? Macam ini tadi dia nak probability of pink. Itu yang dia nak. Kalau ini dia nak probability of seedless. Ini yang dia bergantung kepada siapa. Yang belakang ni dia bergantung, depend on siapa. Ini kan dia depend on seedless. Yang ni dia depend on pink. Okay. Itu saja. So ada apa-apa nak tanya tak untuk exercise yang saya minta you buat? Ada apa-apa nak tanya based on my explanation just now? Ada masa yang tak clear lagi ke? Kalau tak buat dia memang tak clear lah. Kalau you buat tu, you jelaslah apa yang I explain tadi kan. So bila I bagi homework, hopefully that everyone buat lah, cuba buat. So before class, kalau saya tak sempat bincang hari tu, saya nak bincang next class tu, you kena buat. Okay. Alright. So if no question, I will start with new subtopic which is the last part for chapter 4. Okay, we have 2 parts here, permutation and combination. This will not be too difficult for you because you have learned this last time. Okay, in SPM syllabus you have this, permutations and combinations. Okay, cuma mungkin nak ingat balik lah, nak recall balik apa benda yang kita buat dulu-dulu kan. Benda nak belajar tak semestinya kita ingat sekarang ni, dia ambil masa sikit. Okay, tapi I rasa bila I explain tu, there's something in your mind lah. Macam okay, pernah jumpa dulu ni, simbol ni, pernah dengar ni, konsep macam ni. Tapi mungkin kita tak ingat. Okay. So before we discuss in detail about permutation, I akan discuss permutation dulu, lepas tu baru I discuss combination. I want you to know about this one principle, which is multiplication principle. Because later in my ada dalam permutation, in the combination also we will apply multiplication principle. So actually we have applied this multiplication principle before, last week lagi. Waktu kita buat tree diagram, okay, dan kita nak cari apa? We want to find the number of outcome in sample space. So yang you kira you darab tu sebenarnya, dia actually idea from multiplication principle. But last time I tak mention tentang multiplication principle ni sebab kita tak bincang lagi. So I tak sebut langsung lah pasal multiplication principle. So once kita dah masuk multiplication principle, then I can relate balik apa yang kita buat last week. Okay. So what is multiplication principle? So if an operation can be carried out in n ways, a second operation in n ways, then there are n times n ways of carrying out both consecutive operations. Consecutive operations mesti berturutan. Okay, nak faham simple je macam ni. Okay, last week kita ada belajar banyak eksperimen, contoh-contoh eksperimen kan. So in one experiment, we can have many trials. Okay, you can have 1 trial, 2 trials and more. Okay, operation yang dimasukkan dalam ni, trial. So contoh, I bagi I take simple experiment last week. Toss coin twice. Okay, you ada 1 shilling, you baling dia 2 kali and you want to observe the either you get head or tail. Okay, so for the first trial, the outcome is 2. Either you get head or tail. Okay, so number of ways tadi ni, okay, contoh first trial, if an operation can be carried out in m ways. So first trial can be carried out in m ways, 2 ways or 2 outcomes. So trial tadi ataupun 2 cara. So ways dekat sini, kalau kita relate balik dengan eksperimen yang I bagi tadi, example I bagi tu, m is equals to 2. There's 2 outcome or 2 ways. Ada 2 cara. Okay, either you get head or you get tail. Operation berturutan, bersambung. Okay, next will be the second trial. Second trial, I repeat the same trial which is toss a coin and observe head or tail. So in that case, I akan dapat n ways or n outcomes. So in that example, 2 ways. So first trial tadi, I dapat 2 cara ataupun 2 outcome. Second trial, I dapat 2 outcomes or 2 ways. So how do I find the number of operations in that experiment? Ataupun I nak cari sebenarnya number of ways. Okay, kan I kata tadi ways tu sebenarnya outcome. Sebab tu I kata using multiplication principle, actually we want to find the number of outcome in the sample space. So in that case, how do we know how many ways that we can carry out in that experiment? So we just take 2 times 2. Okay, 2 times 2. Ataupun kalau I ada different trial, first I toss a coin, second I roll a die. Okay, first toss a coin, I have 2 outcome. Okay, second roll a die, I have 6 outcome. So how many outcome that I can get from that experiment? So what I do is I just take number of ways for the first trial, multiply with number of ways on the second trial, 2 times 6. So basically that is idea of multiplication principle. So to use multiplication principle, not only for 2 operation, bukan 2 trial je, it can be more than 2 trial. So that's why here they mention it can be extend to more trial or 2 or more operations. Okay, macam mungkin you kata, okay, first you toss a coin, and then roll a die, and then buat balik toss a coin, ataupun you roll a die for 3 times. Tu maksudnya bilangan operation yang you nak buat. Okay, dia bersambung. Dia gabungkan lah, kita gabungkan. So selalunya sebelum ni kita buat nak kira macam mana? Kita akan berpandukan, we will depend on tree diagram kan? Tree diagram. So yang ni applying multiplication principle, we don't need that tree diagram. Okay, contoh. If there are 3 different roads from X to Y and 5 different roads from Y to Z, determine how many roads are there from X to Z. So maksudnya dia berterusan kan? Okay, from X to Y. Okay, ada 3 location. I have location X, location Y and location Z. Okay, from X to Y, I have 3 different roads. Maksudnya ada 3 pilihan jalan yang I boleh guna untuk pergi daripada X ke Y. Okay, this is first operation. So ada 3 outcome lah. Ada 3 outcome. Pilihan jalan tu ada 3. Okay, kemudian I nak sambung saya punya perjalanan daripada Y ke Z. But now I have 5 different roads. Okay, 1, 2, 3, 4, 5. 5 different roads. So the question asks, how many roads are there from X to Z? So daripada X to Z ni combine. So kita combine perjalanan dari tu, ada berapa banyak pilihan jalan. So ni contoh yang kita tak pernah discuss lagi. So ini boleh jadi juga first trial. Okay, 3 different roads. Okay, second trial, 5 different roads. So if we want to know how many roads that we have from X to Z, we combine using multiplication principle, 3 times 5. 3 times 5. So the answer is 15. Okay, kalau you tengok ni pun lebih kurang macam tree diagrams. Macam tree diagram kan. So yang akan dapat ni first road, okay, and then second road, gerak lagi third road, fourth road, fifth road and so on sampai ada 15 pilihan. Okay, 15 pilihan jalan yang kita boleh gunakan. Okay, ini contoh lah. Contoh yang nampak kita apply multiplication principle tu. Okay, ini contoh yang kita kaitkan tadi, ada explain juga ini tadi. Find the number of possible outcome. So kan I kata, using multiplication principle, actually we want to find the number of possible outcome in the sample space. So how do we know? Okay, ini ada berapa trial? Ada 2 trial. First, you toss a coin which consists of 2 outcome. Okay, and then I roll a die which consists of 6 outcome. So if I want to find the number of possible outcome, applying multiplication principle, 2 times 6. 2 times 6. Ini tadi yang saya maksudkan. Okay. Maksudnya eksperimen ni ada 2 trial. Okay, how many sample point there are in the sample space? So sama juga ini, dia nak cari number of outcome in sample space. Okay, if a pair of dice are rolled once. Okay, sebelum ni eksperimen kita buat, kita ada satu die. Okay, we have 1 die and we roll twice. Kan? Maksudnya kita ada satu dadu, kita buat, kita baling 2 kali, kita tak observe dia punya output. Okay, sebenarnya soalan ni dia ada situasi yang sama, cuma dia menggunakan 2 dadu. Okay, 2 dadu. This is the first one and second. Fix lah dadu tu kan? Okay, first and second. Tapi kita baling dia sekaligus. Okay, kita baling dia sekaligus. So, dia punya observation sama macam you ada satu dadu tapi you baling 2 kali. So, sebenarnya kalau you jumpa soalan macam ni, jangan confuse. Sebenarnya dia punya output dia sama. So, contohlah. I baling, I nak tengok observation pertama. So, here I get 1. Kat sini I get 6. So, one of the output is 1, 6. Sama juga macam you roll die. First, you tengok observe 1. Then you roll lagi sekali, you observe dapat berapa? 6. Okay. Ataupun you boleh juga dapat yang first ni you dapat 6, yang second ni you dapat 1. So you punya observation 6, 1. So in this case, sebenarnya walaupun dia roll once, tapi ada 2 trial dekat situ. Trial dia apa? Observation. We observe the first die, that is the first trial, and second trial we observe the second die. Okay, so now we want to combine, we want to see how many possible outcome. So applying multiplication principle, so outcome for the first die is 6. Okay, outcome for first die is 6, ada 6 possibility, nombor 1 sampai 6. Okay, sama juga die yang kedua. Okay, there are 6 possibilities. So applying multiplication principle, if you want to know the number of outcome in the sample space, you are ambil je 6 times 6. So 6 times 6, the number of outcome in the sample space is 36. Okay. So kat sini madam nak tekankan, eksperimen ni walaupun dia ada 2 dadu dan dia baling sekali, okay, sebenarnya sama dengan eksperimen kita bincang minggu lepas, ada 1 dadu tapi kita baling 2 kali. So outcome dia akan sama. Ada 36, lepas tu ordered pair dia pun sama. Ya, so nanti jangan ingat, eksperimen ni macam mana, ada beza ke dengan yang kita buat last week? Tak ada beza, sama je. Okay, setakat ni ada nak tanya tak tentang multiplication principle?
Tiada, madam.
Okay. Okay, now I will discuss about permutation. But before I discuss in detail about permutation, so I want to show you the major difference between permutation and combinations. Why I need to show you this? Because I know that you know, I know that you are familiar with the characteristic of permutation and combination. Bila cakap je, okay, formula permutation apa? Tahu. Formula combination apa? Tahu. Macam mana nak kira permutation? Semua tahu. Okay, combination semua tahu. Apply je lah formula kan. Tapi bila kita beri soalan, tak tahu nak guna apa. Tak tahu nak guna apa. Tak tahu macam madam, macam mana saya nak tahu dia permutation ke combination? Itu jadi isu dia. Sebab apa? Sebab you tak tahu karakteristik dia. You tak tahu apa perkataan-perkataan penting yang kalau kita nampak perkataan tu, kita dah dapat detect dah dia punya sifat. Okay, first of all, kalau you tengok row pertama ni, the first row, keyword that you can see from the statement untuk identify whether it is a permutation or combination. For permutation, the keyword is arrangement, susunan. Benda yang melibatkan susunan, itu adalah permutation. Okay, bila melibatkan susunan ni, contoh macam you nak susun kerusi kan? Nak susun kerusi, Okay, kerusi tu berbeza-beza lah. Mungkin warna kerusi tu berbeza. So, berapa banyak cara I boleh susun ni kerusi ni? Ada 5 kerusi. 5-5 tu warna dia berbeza. So, in how many ways that I can arrange this? Nak letak biru dulu ke? Merah dulu ke? Nak letak merah tengah-tengah ke? Merah belakang? Kuning ke? Macam tu lah. Itu maksud dia permutation. Di situ kita nampak order is important. Order is important meaning the location of the object is important. You want to put the red first or you want to put the red colour on the last part. Maksudnya bahagian yang terakhir sekali. That is what we mean by order important. So pentinglah dua perkara ni. Arrangement, permutation is arrangement and also the order is important. You letak kiri atau letak kanan, dia beza dua tu. Okay, you letak merah kanan dengan you letak merah kiri is different. Okay. But for combination, the keyword dia ada banyak. Okay, dalam combination ni selection, choose, pick, draw, select. So bila benda yang melibatkan you pilih, you ambil, apa lagi? Kalau bahasa Melayu dia banyak guna perkataan pilih, ambil. So kalau English, you jumpa nanti perkataan select, draw, choose. Tu semua tak ada kena-mengena dengan you nak tahu ambil yang depan ke, ambil yang belakang ke, ambil yang tepi ke, kanan, kiri ke. Kalau tak ada kena-mengena dengan order, meaning that is a combination. That's why they say here order of object is not important. Okay, for example, you have a box. Okay, inside the box, you have balls, 5 balls with all different color. So now you want to choose or you want to select 2 balls. In how many ways that you can do that? Maksudnya berapa banyak cara you boleh ambil bola tu. Ada 5 ni, ada 5 warna. So mungkin you boleh dapat bola biru dan merah. Okay, atau bola merah dan hitam. Okay, so kalau consider bola biru dan merah, okay, biru dan merah, sebenarnya dia sama dengan you ambil bola merah dan biru. Merah dan biru. Sebab apa tadi? Order not important. Merah biru atau biru merah tu tak kisah. As long as you ambil 2. Syarat dia kata apa? Select 2. Okay, ambil lah 2. So ambil biru merah. Kalau you dapat merah biru pun, it's the same thing. You kira sekali saja. Tapi kalau you susun bola tadi, nak susun biru merah, berbeza. You nak susun biru dulu ke, you nak susun merah dulu? Itu maksud dia order important. Okay, for combination, order is not important. If you can understand this characteristic, so bila you baca soalan, you tengok soalan tu karakteristik dia dekat mana? Order important or order not important? Ada tak perkataan ni? Arrangement, selection, pick, choose, draw. So benda-benda tu yang akan bantu you untuk jawab soalan permutation, combination. Sebenarnya dia tak susah. Dia tak susah kalau you faham konsep ni. Okay. So memang akan banyak application lah. Application question on permutation, combination. Formula dia simple je. Formula dia even you tak payah guna formula pun. You guna calculator saja. Calculator you ada command P kan. P, yang capital P tu. P is for permutation, C is for combination. Yang jadi isu susahnya kat sini, you nak fahamkan soalan tu. Dia nak kira permutation ke nak kira combination? Okay. Now I will discuss in detail about permutation. Okay, so nanti lepas permutation baru kita bincang pula combination. Okay. So tadi kita kata permutation is the process of arrangement. When you arrange something, okay, order important, meaning that is a permutation. The number of permutation refer to the number of arrangement. Basically permutation ni dia perkataan lain kepada arrangement lah. Okay, kadang-kadang soalan tu akan tanya number of arrangement. Okay, ataupun ditanya number of permutation. Sama je, perkataan maksud permutation dengan arrangement tu adalah benda yang sama. Okay. In permutation, we have 4 different situation. Okay, dalam permutation ni 4 different situation that allow you that need you to use 4 different formula. Okay, 4 formula yang you akan guna nanti bergantung kepada 4 situasi yang berbeza. Okay, I go one by one. So ini yang pertama lah. Okay, so formula for finding the first permutation, the number of permutation is using factorial function. Formula dia n factorial. N factorial. So what is n? N is the number of object. Okay, macam tadi kan I bagi example 5 balls. Tak naklah bola susah lah nak susun bulat kan, nanti gerak-gerak. Kita ambil buku lah. Okay, I have 5 different books. Okay, I have 5 different books. Okay, maybe the color is different, the title is different, everything is different. I want to arrange the books. I want to arrange all the books, 5 books on the shelf. Okay, in how many ways that I can arrange them? Dalam berapa banyak cara I boleh susun dia? In how many ways that I can do the permutations? Okay, do the arrangement. Okay, provided that all the object must be distinct. Distinct maksudnya different. Lepas ni you akan jumpa perkataan distinct. Distinct tu maksudnya different. Okay, all the object must be different. So tak boleh ada buku yang sama. So 5 buku tadi mesti semua 5-5 berbeza and you want to arrange all of them. You bukan nak kata arrange 2 ke 3 ke, tak. You nak arrange semua. So if you want to do that, you will apply this formula to know how many ways that you can arrange. So for example, I have 5 books just now. In how many ways that I can arrange the books? So I apply the formula 5 factorial. 5 factorial. So you will calculate. Sama ada you nak buat 5 darab 4 darab 3 darab 2 ataupun tekan calculator je 5 factorial. So dia bagi jawapan. Okay, 5 factorial, they give you the answer. Okay, that is for formula number 1. The characteristic dia mesti all distinct object and you want to arrange all. Maksudnya kalau ada 10, you nak susun 10-10 tu. 10-10 objek tu pula mestilah berbeza, bukan objek yang sama. Okay, that is formula 1. Formula number 1. Okay, this is the example. Consider 3 letter ABC. So obviously ABC are different letters. So kita boleh apply lah yang first. And we want to arrange all letters in a row. Okay, we want to arrange in a row. In a row maksudnya dalam satu barisan, dia ada starting, dia ada end. So for example, I can arrange this like this. A, B, C dalam satu baris. So starting A, last with C. Or I can arrange them B, C, A. So starting B, last with A. Okay, determine the possible permutation and the number of permutation. So I want you to know how do we answer these 2 questions. Okay, mana satu yang jawapan dia mesti diberi dalam nombor, mana satu jawapan diberi dalam bentuk list. List tu maksudnya jenis susunan dia, bentuk susunan dia macam ni. A, B, C, B, C, A, B, A, C. Ini sebenarnya jawapan untuk bahagian A. Okay, the answer for part A, the possible permutation or the possible arrangement. Possible arrangement. So I can arrange this like this. I can arrange them like this. A, B, C, B, C, A, B, A, C. And to know how many of them, so that kita macam tahulah bila nak berhenti kan, berapa banyak nak kena buat ni. So kita akan cari number of permutation. So number of permutation tadi yang you guna n factorial. Tu yang tadi you guna n factorial. So kita nak tahu in how many ways that I can arrange these 3 letters in a row. So you will substitute the value, the number of object in this formula. So n is equals to 3. How I know 3? Calculate how many object? 1, 2, 3. How many letters? 3 letters. 1, 2, 3. So 3 factorial. Okay. So there are 6 distinct arrangement, which is 3 factorials equals to 6. Okay. And the possible permutation yang A tadi tu yang I buat tu, A, B, C, ACB, BAC, BCA, CAB and CBA. So perlunya nilai ni so that kita tahu kita dah listkan semua. Kita dah listkan semua. So you kira ada 6 tak? 1, 2, 3, 4, 5, 6. So cukuplah you punya list possible permutation. Okay. So kalau anda kata dia kata okay list soalan ni kan. A kan? Determine the possible permutation. Determine the possible permutation. Lepas tu you bagi jawapan 6 dekat A ni. You bagi jawapan 6 nombor, which is wrong. So you akan dapat 0 marks. Sebab dia bukan nak number of permutation. Dia bukan nak number of arrangement. Dia nak apa dia punya permutation. Apa dia punya arrangement. Sebab tu kena baca betul-betul soalan tu. Dia minta number of ataupun kadang-kadang dia kata number of. Kadang-kadang cakap how many. How many permutation. How many arrangement. Tu maksudnya kena bagi dalam nombor. Tapi kalau dikata list the permutation, list the possible permutation, list the possible arrangement, meaning you need to list all this. Okay? So kena tahulah detect soalan tu nak apa. Ada soalan setakat ni?
Tak ada.
Okay, so settle first formula for permutation. Okay, now we go to second formula. Okay, second formula still need you to consider all distinct object, all different object. Kalau tadi kita ada 5 buku, 5 buku tu kena berbeza. Okay, kalau yang tadi first, we want to arrange all the books in a row. But now, instead of we arrange all, I want to arrange some of it. Okay, some of it. Mungkin I want to arrange 3 books at a time. Daripada 5 buku tadi. Ada 5 buku yang warna dia berbeza. So, berapa banyak? How many permutation that I can do on the shelf? So, I nak susun 3 buku je dekat shelf tu. Tapi ada 5. So, mungkin merah, biru, kuning. Merah, biru, hitam. Okay, merah, biru, hijau. Okay, lepas tu tukar pula yang lain. So in how many ways that we can do, nak tahu berapa banyak cara kita boleh buat, tu yang kita guna P tadi tu. NPR. Okay, NPR. So what is N? N is the number of object. Okay, if I have 5 books, so here will be 5. Okay, R will be how many object that you want to arrange. Berapa banyak daripada 5 tu, berapa you nak arrange? 2, 3. So you can put here. Okay, kalau guna calculator, you akan press 5P2. 5P3. But if you want to put in this formula, dia akan jadi 5 factorial divide by 5 minus 3 factorial. Okay. So sama je kalau you guna ni pun, you kena press calculator juga kan. So since calculator kita ada command untuk yang ni, terus guna sajalah, tak payah nak guna factorial ni. Okay. So second formula, when you want to arrange R object at a time from n distinct object. Okay. Contoh list all. So list all the possible permutation. So ni bukan dia nak minta nombor. Dia kata list all the possible permutation. Kalau ditanya how many permutation, baru you bagi nombor jawapannya. So kat sini list all the possible permutation of letter A, B, C, D taken 2 at a time. So you bukan nak susun 4-4 ni. You nak susun 2 saja. Okay, you nak susun AB ataupun AD ataupun AC ataupun BA. AB and BA tak sama tau. Okay, AB and BA tak sama sebab AB, A dulu kemudian B. Kalau BA, B dulu kemudian A. Ni yang tadi kita kata dia order is important. So before we list all this, guideline kita nak tahu berapa banyak nak tulis, tu yang you kena cari the number of permutation. Guna formula tadi. So once we know the number of permutation, okay, berapa banyak objek? Kita ada 4 objek. Okay, nak susun berapa banyak dalam satu masa? Nak susun 2 saja. So you will use this, find the number 4P2. Okay, 4P2. So you dapat 12. So meaning that bila you list, make sure ada 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we have 12 possible permutation. So jawapan yang kita nak tengok untuk soalan ni adalah yang ini. Bukan 12. 12 ni hanya sebagai panduan kepada kita nak berapa kita nak listkan. Okay. List all the possible permutation 2 at a time from 4 object. 4 different object. Okay, nombor 1, nombor 2 dah settle. Okay, yang ketiga. I kata dia lupa kan? Okay, the third formula, when you want to arrange all distinct object, semua distinct object. Okay, kalau you tengok the first and second, you arrange in a row. Maksudnya ada starting, ada end. But for third formula, you will arrange them in circle. In circle. Okay, for example, I bagi yang simple saja. I have 3 letter. And I want to arrange this letter in circle. So dia tak ada starting, dia tak ada end. Bila dia circle, dia akan pusing kat situ. So starting dengan end dia berubah-ubah. Okay, one way that I can do this, okay, I boleh buat macam ni. A, B, C. So you letak arrow sikit lah. Bila letak arrow, you nampak lah. Either you want to put it clockwise or anti-clockwise. Pilih salah satu. Nak clockwise ke anti-clockwise. Ini salah satu contoh. So here, okay, dia punya arrangement dia akan jadi A, B, C. Ataupun you boleh kata dia B, C, A. Ataupun C, A, B. Walaupun you nampak macam banyak, tapi sebenarnya dia ada satu saja. Okay, dia bersambung ni. A, B, C, A, B, C, A, B, C, A, B, C, A. Pusing kat situ. So this is one way. So another way is you akan ada A, C, B. Yang ni tak sama tau. Macam mana nak tahu tak sama? Cuba tengok. A, B, C. Okay, lepas A, B. Yang ni lepas A, C. So these two arrangement is not the same. Ni berbeza. So how do we know that how many arrangement that we can do? Okay, macam mana kita nak tahu berapa banyak kan? Sebab tu kita akan guna formula ni. N minus 1 factorial. So what is N? N is the number of object. So here I have 3 object. So 3 minus 1 factorial equals to 2 factorial. 2 factorial is 2. So meaning that the number of way that I can arrange ABC in circle is only 2. Which is this. There's no other than this one. Tak ada lagi selain daripada 2 ni. So usually the number of arrangement in circle will be lesser than number of arrangement in a row. Tadi you dapat ni, kalau you nak susun ABC 3-3, you akan guna factorial function kan? You akan guna 3 factorial. Okay, 3 factorial. So 3 factorial is 6. So you ada banyak lah ABC, ACB, BCA. Itu sebab tu yang kata tadi, arrangement in circle will be lesser than arrangement in a row. Okay. Contoh lain. In how many ways 6 tree be planted in a circle? Okay, maksudnya dia nak tanam pokok tu dalam bentuk macam ni. Okay, mungkin kita tengok clockwise lah. Okay, ataupun anti-clockwise. And our assumption here, all the tree should be distinct, different tree. Pokok yang berbeza. Mungkin dia nak tanam satu tu pokok rambutan, satu pokok durian, satu pokok manggis. Tapi dia mungkin kawasan kebun yang besar kan, tapi dia nak letak dalam circle. So in how many ways that they can do that? Okay. So kalau kat sini, you tak akan guna 6 factorial. You akan guna 6 minus 1 factorial to know how many permutation. Okay, 6 minus 1 factorial equals to 120, which is 5 factorial. 120 ways. Okay, number of arrangement that we can do this in circle is 120. Okay. So macam mana kita nak tahu nak guna formula ni? Bila dia ada cakap arrange in circle. So kalau dia tak ada sebut pasal arrange in circle, kita terus assume that is arrangement in a row. Okay, sebab jarang soalan dia kata arrange in a row. So bila dia tak ada sebut arrange in circle tu, automatic you terus pergi arrange in row. Formula 1 and 2 tadi tu. Formula 1 and formula number 2. Okay, last formula for permutation. Okay, for the fourth formula, kalau you notice formula number 1, 2 and 3, all the object involved must be distinct. All the object involved semua kena berbeza. Kalau ada buku tadi, ada 5 buku, 5-5 tu kena berbeza. Okay, ada juga keadaan soalan permutation ni, dia akan tanya di mana akan ada identical item, identical object. Okay, contoh macam you want to arrange book, okay, 5 books, but 2 of them is identical, same books. Okay, same title, same size. So maksudnya dia dalam kategori yang sama. So bila dalam kategori yang sama, you susun di kiri kanan pun tak defect. Okay, kalau di dalam macam contoh macam letters, you want to arrange the letters, huruf. Okay, you ada 4 huruf A. So you nak susun huruf A tu 4 tu, you letak mana-mana kiri kanan takkan effect. So dia kira sekali lah A tu. Jadi kan? Sebab dia benda yang sama. So untuk nombor 4 ni, formula number 4 is used when you have an identical object. Identical object. Okay, so the formula we will use is this one. Ni formula yang kita akan guna. Okay, where the numerator is n ni, maksud dia the number of object. Okay, contoh you ada 5 books, tak kisahlah identical ke tak. Okay, as long as total book tu ada book berapa, ada 5. Okay, then you can letak 5 factorial. Okay, if let's say kalau tak ada identical, tak perlu pun bahagi yang bawah ni. You akan guna tadi kan first factorial function tu. You akan guna first tadi kan n factorial saja. But kalau you notice ada repetition, maksudnya ada identical object, then baru you divide by, baru guna formula yang keempat ni. Divide by, so what is N1, N2, N3 and K ni in general. Okay, N1 meaning the number of, okay, identical tadi. Okay, contoh you ada 2 red books. So the number of red books yang identical tadi 2. So kat sini jadi 2 factorial. Okay, multiply with, okay, maybe the next one you ada 2 yellow books. So you will multiply with 2 factorial. And remaining with 1 book kan? So you multiply with 1 factorial. Okay, so itu cara dia macam mana kita nak guna formula nombor 4. We only use formula number 4 if there is a identical object. And of course we will arrange this in a row, bukan dalam circle. Mesti arrange dia dalam row. Okay, arrange dia dalam satu barisan. Ada starting, ada end. Okay. Macam ni. How many arrangement can be formed from the word technology? Okay, daripada perkataan teknologi ni ada berapa huruf? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total we have n equals to 10. But we notice there are similar letters, which is letter O. So bila you ada similar letter kat sini, you tak boleh guna formula number 1. You need to apply formula number 4. Okay, you nak susun semua, tapi sebab ada yang berulang, ada huruf yang sama, ada objek yang sama. So you will use the formula. Okay, n factorial, so 10 factorial, divide by, okay, mana tadi yang ada identical? O kan?
Oh,
Ada berapa?
2.
So you will put here 2 factorial. Okay, how about the remaining? Actually the remaining, you need to put 1 factorial, 1 factorial, 1 factorial, 1 factorial until 8 times. Sebab ada balance lagi 8 huruf. But because of, we know that 1 factorial is 1. So we don't have to waste our time to write all this 1 factorial. So just ignore this part. Dan you hanya akan tulis 10 factorial sahaja. Divide by 2 factorial. Yang ni bukan R. Kalau tengok formula tadi, this is not R ya. This is N1. Okay. This is N1. Okay. N1 maksudnya ada objek yang number of object which is have a similar category, in the same category. Okay. So kalau you nak buat 2 factorial times 1 factorial, 1 factorial banyak-banyak tu pun tak ada masalah. Tapi kita buang masa lah sebab kita tahu 1 factorial is 1. So just ignore that part. So you hanya akan bahagi dengan identical object. You only divide with identical object. If there's no identical, no need to divide. Just 10 factorial. And we must arrange all. We must arrange all. Okay. How many arrangement can be formed from following letters? So how many of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10. But I see the identical. I have 4A, 2B, KEG. Tak payah. So I have U. So this one become 4 factorial, 2 factorial, 2 factorial. So dia jadi 10 factorial divide by 4 factorial times 2 factorial times 2 factorial. Okay, ni N silap. N. Okay. Sekarang bola. 5 red ball, 2 white ball, 5 red ball, 2 white ball, 3 blue balls are arranged in a row. How many of them? 10 balls. Okay, I have 10 balls, 10 factorial. But because of, we see identical. If all the ball of the same color are not distinguishable. Are not distinguishable meaning these 5 red ball tak boleh nak dibezakan, meaning they are in the same category. Are not distinguishable maksudnya dia tak boleh nak dibezakan, tak boleh nak dibezakan. Okay, so it is in the same category. Sama juga dengan white and blue. Okay, so sama kategori lah. How many different arrangement are possible? How many? So kena bagi nombor. Berapa banyak cara. So because of they are identical, okay, you akan divide by 5 factorial, 2 factorial, 3 factorial. So the answer is 2520 again. So this is N. N1, N2, N3. Nanti confuse pula dengan formula kan. Tadi dah bagi N, tiba-tiba R. Okay, setakat ni ada soalan tak? Jelas tak untuk empat-empat formula?
Jelas.
Kalau untuk formula pertama kan N factorial. Contoh macam tadi yang A, B, C, D tu. Kalau dia minta list possible permutation, kita letak dalam table tu kira list ke sudah?
Boleh. Asalkan you tunjukkan dia punya ada A, B, C, D tu kita nampak. And then apa dia? A, B, C, D and then A, C, D, B. Mesti ada lah. Kalau ada 12, mesti ada 12. Tak kisahlah nak guna table ke, nak guna macam mana method yang you nak guna, terpulang. So kalau ada 12, make sure ada 12 you nyatakan. Kalau ada 20, kena ada 20 you kena list kan. Dalam bentuk table ke, dalam apa-apa saja yang tree diagram ke, apa yang memudahkan you, yang cara you nak buat, asalkan mesti ada bilangan dia. Kalau 10, make sure cukup 10. Okay. Method macam mana nak guna, table ke, tree diagram ke, apa-apa yang you pernah belajar dulu, buatlah, tak kisah, tak ada masalah. Boleh diterima. Okay, ada soalan lain? Okay, if no question, ni soalan daripada page 20. Okay, you boleh tengok you punya modul. I tak buat sekarang. I will discuss this at the end of the class after I habis discuss combination. Okay, so question 4 and 5. This question related with multiplication principle. So ambil je dulu nombor soalan. Boleh tengok dekat modul page 20. Okay, question 4 and 5. This question related with multiplication principle. Okay, ada lagi soalan lain? Okay, yang ni tak ada dalam modul. I bagi you extra exercise, soalan extra. Okay, maybe you boleh screenshot ataupun you snap picture. Nanti dekat hujung kelas kita akan jawab balik soalan ni. Okay. So basically ada 3 soalan yang kita akan bincang, tapi kita bincang di akhir kelas nanti. Okay, tadi 2 soalan, 45, page 20. And then ni lagi 1 soalan. Okay, snap picture dulu. Nanti sekarang kita bincang balik. Okay, so sebelum kita sambung permutation, sebelum sambung combination, kita rehat sekejap 5 minit. Nanti pukul 3 kita sambung balik Okay, soalan exercise ni kalau nak try buat dulu pun boleh. Tapi kita akan bincang sama-sama nanti dekat hujung kelas. Right. Okay, siapa yang masuk kemudian tadi, please tick attendance dekat Putra Belas ya. Okay, thank you.